Okay, stats, we're going to go ahead and knock out 6.1 and 6.2 in today's videos. We'll start with some refreshers. A discrete random variable. First, a random variable is just a measure of the outcome from a probability experiment. So it's a random chance. If it's discrete, that means it has to land on certain numbers, certain distances between each point. Usually there's a finite amount of options or a countable number. A continuous random variable can be anywhere in the middle, has an infinite number of options. So to remind yourself the difference between these two, let's look at the bottom, determine whether the following random variables are discrete or continuous, state some values. The number of light bulbs that burn out in a room, 10 light bulbs in the next year, that's discrete. It either burns out or it doesn't. And it could be anywhere from 0 to 10. I guess all the light bulbs could burn out. It's not super likely, but possible. The number of leaves on a randomly selected oak tree. Okay, so this is one of those things where you're like, well, you either have a leaf or you don't. But it says it's countable. Now, if you took a really big oak tree, could you ever count all the leaves it has on it? No, so I would call this continuous because it's infinite. Or nearly, it's essentially infinite, not technically. The length of time between calls to 911, also continuous. These days, you probably get less time between calls to 911 because every Karen in the world is probably calling due to the fears they have over literally everything. Okay, so besides discrete and continuous, there's more refreshers in 6.1. A probability distribution provides all the possible outcomes for a variable and the corresponding probabilities. We've talked about this before as well. There are only a few rules. All the probabilities need to add up to 1, and all of them have to be between 0 and 1. So we've done these before, so you can do more of these yourself, but the notes, completed notes are posted online. We've done these before. Okay, so sometimes you need to make your own probability distribution. Let's talk about the probability distribution for a coin being tossed 2 times, and x being the number of heads. So you either get 0, 1, or 2 heads. What are the chances of getting 0? Should be 1 in 4. 2, 1 in 4. And this one is 2 out of 4 because you can either go heads, tails, or tails, heads. And so that's it. It's just the table. A 6-sided dice roll, what are the outcomes? 1 through 6. And each of them has an even chance, 1 out of 6. So these are probability distributions. I think you guys can handle them. Now, a probability histogram is a histogram in which the horizontal axis is the value of the random variable and the vertical one is the probability. You can kind of think of it as very similar to a histogram for relative frequency, because probability and relative frequency are intertwined, mean similar things. So if you want to draw it based on the number of movies streamed on Netflix each month, it's from 0 to 5 down at the bottom. And we go as high as 0.58, so I'm going to go by 0.1, 2, 3, 5, 6. Okay, 0.06. 0.58. 2 has 0.22. 3 is 0.10. 4 is 0.03, so it's short. And 5 is 0.01, shorter. So the histogram is still the same type of histogram you've done in the past, so it shouldn't be something new. We'll skip number 2. You can do the other histogram if you want. Let's get to things that are actually slightly more difficult. The mean of a discrete random variable is the sum of all numbers times the probability of those numbers. So when it says compute the mean of the probability distribution to the right, which is the number of TVs in a household, what you do basically is you look at the table and you multiply x times the probability of x. 1 times 0.32 is 0.32. 2 times 0.51 is 1.02. 3 times 0.12 is 0.36. 4 times 0.05 is 0.2. And you just add them all together. So when you add these all together, you get a total of 1.34, 1.7, looks like 1.9. So all it's saying is multiply the number times the probability and add them all together to get your answer. So find the mean of the probability distribution to the right, which represents, again, the number of coins tossed or heads tossed. We'll copy it from before. So again, we multiply. 0 times anything is 0. 1 times a half is a half. 2 times a quarter, 2 quarters, you have a $half. What's 0 plus a half plus a half? 1, which means the expected value is 1 head out of 2 flips, which makes sense. If you flip a coin twice, you expect to get 1 heads and 1 tails on average. So what is the interpretation of the mean of a discrete random variable? So suppose an experiment is repeated n independent times and the value of the random variable is recorded. As the number of repetitions of the experiment increases, the mean value will approach our expected value. All they're saying is if you flip a coin twice or flip 2 coins and you repeated this trial hundreds of thousands of times, you should get really, really close to exactly 1 heads per 2 flips. Basically, the more you do it, the more things should offset over time. Now, if they ask you for the expected value, it's really the same as the mean of the random variable, where you multiply the amount times the probability and add them all together. So amount times prob. So calculate the expected value. 0 times anything is 0. 2,000 times 0.15 is 300. 4,000 times 0.08, 320. 6,000 times 0.05, 300. 8,000 times 0.01 is 80. 10,000 times 0.01 is 100. When you add all these together, you get 3, 9, 20, 1,100. What does that 1,100 mean? Well, let's look at the word problem first. A car insurance company has determined the probabilities for various claims amount for drivers aged 16 to 21. So these are all the car insurance claims that kids are making. And when you add the expected value, you get 1,100. That means the expected amount of claim over the long haul is $1,100 per driver. That's all they're really asking you to do. Now, a much more realistic problem. It's a life insurance policy pays a beneficiary a certain sum of money upon the death of the policyholder. Oh, we had part B on the previous question. We'll go to number 2 in the next video. How much should the company charge as a premium so the company makes $50 per policy? If each policy on average costs them $1,100 and they want to make $50, they need to charge $1,100 plus $50 or $1,150. And we'll continue this and move to 6.2 in the next video.